Alright, good morning everybody. This video is intended to walk you through everything you need to do for today's lesson. So we're starting as we would with a regular class. If you would turn to page 41, there is a scenario there called auto loan, and there's a chart that goes with it, and I'd like you to answer questions numbers 1 through 3. So you can pause your video here and answer those 3 questions as carefully as you can, and then unpause the video once you are done. Alright, we should all be on page 41 now, and we're going to go through that problem just to make sure everybody did it right. So first off, again, one more time, if you did not do these problems yet, you should pause and try them first so that we can actually be working off of something here. Alright, so Morgan recently bought a used car. They took out an auto loan for 12 grand at a fixed rate of 4.8, and the table below shows the balance over time. So when no months have gone by, the loan is at its full balance, $12,000. After 1 month, we've done our 1 plus formula, and you can see the 4.8% interest rate right here, and it's being divided by 12 because it's monthly. But then we're throwing in a little bit of extra thing in here, this minus 225. So that's new to us, right? We haven't seen that before. So you can speculate what that means at minus 225, and we get a new amount. Then month 2 works off of the previous month's amount, so we're starting with 11,823. And we do all the same things. So we're doing 1 plus our interest rate over 12, subtracting 225 again, we get a new amount. Month 3 starts with the month 2 amount. So every time we go to a new month, we're starting with the previous value, which works like a recursive sequence. So that's how what we discussed in class most recently last week, that a recursive sequence relies on the previous term in order to generate the next one. So we keep on relying on the previous amount, applying the same formula, getting a new amount. So if we're going to describe the pattern of how the loan balance changes, one thing we're doing is we're adding the interest amount. So that's what the 0.048 over 12 does. And then we're subtracting 225. So that's the pattern that's being established here. How do we know it's recursive? It's because we are using the previous balance every time. So whenever we generate a sequence by using the previous number, that's called recursive. How much does Morgan pay toward their auto loan each month? Well, that's the new part of this formula that we hadn't seen before. So the part of the formula that is new to us is this minus 225 on every level. So that would be the monthly payment. All right, every time they pay that, it comes off the balance, and so we end up with a lower amount, subtracted every time. All right, so hopefully you're able to get those 3 parts on your own. But if not, take the time to revise them now. You can pause while you do that and make sure everything is accurate there. And then we're going on to page 42. Alright, so extending this problem, Morgan's annual interest rate is 4.8. What is their monthly interest rate? So we get a monthly interest rate simply by dividing the yearly interest rate by 12. And that was part of the formula that we just looked at. The fraction part was taking the yearly interest rate divided by 12. So this is now the monthly interest rate, which would, if you move the decimal point, would be 0.4%. Okay, so write the recursive formula to find their balance after n months. Recursive formula has 2 parts to it. So we have a term 1 and we have a term n. The term n describes the rule. The term 1 describes where it begins. So I'm starting at $12,000. Now every time a month goes by, I'm going to multiply 1.04 by the previous amount. So Fn minus 1 is the previous amount. So whatever I look at a row above, that's the Fn minus 1. And then if I subtract the 225, I have it. Now where did I get 1.04 from? Well, you have to think about our formula having a 1 plus a fraction. So if we just replace the fraction with the 0.004 and then add 1 to it, this is what we have. So if you want to think of it as 1 plus a fraction instead, because you're used to that, that's totally fine. You have to multiply that by the previous term and then subtract 225 in that order. Alright, so if I want to find month 5, after month 5, what I need to do is multiply by month 4. Okay, so I take this 1.004 times month 4, which would increase it, adding interest, then subtract the monthly payment and we'll get our new amount. So if you look back on the table, month 4 was 11,288. So I replace f of 4 with 11,288. Multiply, subtract. So again, that's from the table. And when I multiply and subtract, I should get 11,108. Okay, so at this point, grab your calculator if you haven't already done this, which you probably have, but if you haven't, multiply this out, subtract the 225 just to confirm that you're able to get 11,108. Everybody's got to be able to do that on their own, so just check it now and make sure. Okay, going on to number 7. Alan reviewed Morgan's loan information. It says, I think it's going to take 53 months to repay. Found that estimate by dividing by the monthly payment. So if you divide 12,000, the original loan, by the monthly payment, you get 53. Is Alan correct? All right, so make a guess first in this space. Write down whether you think Alan is correct and why. And pause the video to write that down. We'll come back and talk about it. Okay, so it's not correct because we're not including the interest accrued that also needs to be paid off. So dividing by 225 would be an interest-free loan. But every time we go a new month, we're doing that times 1.004 step. So it's increasing first and then decreasing by 225. It is not just subtracting 225 every month, which is what this division implies. So this would be if you had a 0% APR and you were just going to pay it per month, you would divide. But if you have interest, you have to calculate that first. Okay, so moving on to level 2. It's about student loans. So Jada recently graduated from college, $34,000 in federal student loans, and the fixed interest rate is 3.73. It's compounded monthly, and then she makes a monthly payment of $340. She'd like to pay those loans off in 10 years because that's what student loans require you to do. All right, so first, get the monthly interest rate. Do it the same way we just did the auto loan. Take the annual interest rate and figure out what the monthly interest rate will be. And pause and do that. All right, so we should have been dividing the interest rate by 12, and then that's your percent. If you did it with a decimal version of an interest rate, so 0.0373 divided by 12, you would have gotten 0.00311, which is correct, but then if it wants it as a percent, you have to move that decimal point back into position anyway. So that's why the original work I did here just kept it as a percent and then changed it back. And you would not be allowed to do it this way within a formula. Within a formula, you have to make it our decimal version. But if the question's just asking for a percent, you can keep it as a percent and write it that way. All right, so that's number 1. All right, let's go on to the next page, to number 2. And we're asked to complete the table with Jada's loan balance over the first 3 months of payment. So I have 0 months here, which is what the loan started at. And the process, you'll recall from the auto loan, is to multiply the interest by the amount and subtract the monthly payment. So the way I got this number was to take 1 plus and then take the decimal version of the monthly percent, so 0.00311. And if you just consolidate that, it becomes easier to type on your calculator. Multiply by the previous amount of loan balance and subtract the monthly payment. All right, so pause here and do that calculation. All right, so you can check. We should have 33,766, which means not a whole lot came off of that original amount. Certainly not $340 worth, because this is only $234 less. So that means a lot of money went to interest first, and then we subtracted the payment. All right, so for month 2, we have to take month 1 and replace this part of the formula. All right, so this part of the formula decreases every time to what the previous balance was. So try to write the formula replacing 34,000 first. Okay, so that would look like this. So you notice the interest rate part is the same. The minus 340 part is the same, but now we have a new balance that's being used for month 2. Okay, so multiply that on your calculator, pause it, and figure out what that new balance would be. All right, we should have 33,531. So now we took off $235, which is less than the first month. Not a lot less. I mean, not a lot more, but it's a little bit more. Every month that goes by, you're going to be widening this gap more. You're going to be paying off more because the interest effect gets lower as we multiply by lower numbers. So every time we get a new month, this balance gets lower. So when we multiply by the interest, that part gets lower, which means we're actually chipping away more at the total balance. All right, month 3, it's going to be just like month 2, but we have to replace the balance with the new balance. So write that formula down first, pause and do that. And we should have 33,531 in the position that we multiply by. Multiply that out and get your new balance. And I've got $33,295. So this time we paid $236. All right, it's paying a little bit more all the time. Now, as this went up and up in months, remember this is a 10-year loan. So 10 years is a lot of months, right? That's 120 months. So at the beginning, you're not increasing your gap that much. But as time goes by and you keep on reducing this balance, the interest part of it becomes less, and you end up paying more and chipping away even more. All right, so describe how you could use the third month's balance to find the fourth month's balance. It's simply doing exactly what we were just doing. We would just change the balance to the month 3 balance, multiply and subtract. It's called a recursive formula for that reason. All right, so number 4, we're going to try to go through and summarize here. When we do a recursive formula, remember we have to write down term 1, which is our starting amount, and then we have to write down term n, which is to explain what operations are happening to the previous term. When you write previous term, remember it's f of n minus 1. So I'd like you to just pause here and try the best you can to fill in this formula. All right, so term 1, if we go back to our starting amount, it was 34,000. That should be the easy part of the formula. You just look at the beginning. Now we have to write down what we're doing. So we're multiplying by the 1.00311, and what we're multiplying this by is the previous term. So this part of the formula needs to be in there every time because we have to be multiplying by the previous amount to be recursive. And then also we're subtracting our monthly payment. So you could write it that way, or again, like last time, you could keep it as a fraction, but we have already been simplifying it to this, so I'm guessing most of you wrote it this way, like in number 4, just pulling it from the table. But if you wrote it this way, that's also accurate. All right, the last thing I'd like you to do in this part of the packet is, we're not doing number 5 here, so I've deleted that. If you can find space at the bottom of 43, you can use that, or you can grab some extra paper, and we just want to practice this. Practice, just like we did in class last week, practice taking a sequence and turning it into a formula. So I'm going to put up 2 at a time. We'll do A and B first. These are sequences that have a pattern. What I'd like you to do is write down what term 1 would be and what the rule would be, having an n minus 1 in there. All right, so pause and do that and come back and we'll talk about them. All right, what everybody should have had here, and again, if you haven't done this yet, please pause and try it first. What everybody should have here for term 1 is just the first number in the sequence. So both of these are going to be the very starting number in the sequence gets written first. Now for the rule, hopefully you all saw that this is up by 7, increasing by 7. So what we do is we take the previous term, f of n minus 1, and we add 7. So that's the second part of the rule. This fn minus 1 has to always be there. All right, in part B, this is not as easy to see. So it's up 4, and then it's up 6, and then it's up, oh, that's a mistake. Okay, that 17 is supposed to be a 27. All right, so it's up 4, and then it's up 6, and then it's up 9. So the amount that it's going up by increases, so we can't just add. So maybe what you saw is that the amount that it adds is half of the previous amount. If you saw that, then you would know that it's times 1.5. And so if you multiply by 1.5, you would have 1.5 times previous term. Now when you go to delta math, you have to enter it differently, because remember, it's not using F's in delta math, it's using A's. So the formula would say AN, and you would use AN minus 1 plus 7. So it's the same things that you're doing, it's just putting an A instead of an F. And you have the same thing over here, 1.5 times AN minus 1. All right, a couple more for you to try, and then we'll be finished with this part. So pause here and try to write your rule. Okay, term 1, 2700. Term 1, 5. That part's simple. For Fn here, we need to notice what's happening. So it's possible that you wrote down divide by 3. Or it's possible that you wrote down multiply by 1/3. Either one of those totally works. So if you did the divide by 3 version, it would look like this. If you did the times 1/3 version, it would look like this. Both of them are totally acceptable. On delta math, it's going to do times 1/3, just so you're aware of that. I don't think there's going to be a divide button for you to use. So you would do the fraction version. And over here, we go 5, 13, 29, 61. So this is a scenario where it's definitely not just plus because it's increasing, but it's also not times anything. So what we could do is figure out how do we get close to 13 with multiplication. So try times 2, try times 3, try times whatever you want. When I try times 2 here, 5 would become 10, and then I'm 3 away. So times 2 plus 3 would work there. So then you just try that again here. If I do 13 times 2, I get pretty close to 29. I get to 26, and plus 3 would work. 29 times 2 would be 58, and again, that's plus 3. So times 2 looks like this, and then plus 3. And that Fn minus 1 goes in there. If it's delta math, it's just going to be the same thing, 2 times the previous term plus 3. Okay, speaking of delta math, your delta math assignment that is going to be due on Friday is called recursive sequences. And so the first task in there is just labeled for recursive sequences. Second task is labeled write recursive formula. Third task is titled select recursive formula. So I'm just going to quickly go through all 3 of those so that you can get started on it. The ones that say recursive sequences look like this. So it gives you the first term, and then it asks you for the 5th term. Right? So we need to make a list in order to do that. So my first term is 7, and then I have term 2, term 3, term 4, term 5. This is the one that I want. So what I need to do is use the rule here. This says times 2. So if I take the previous term and times 2, I'd have 14. Do it again, I have 28. Do it again, I have 56. Do it one more time, and I have 118. So over here in the answer, I would just write 118. It doesn't want you to write a 5 or anything like that. Just write what that final term would be. So when you're doing these, just grab a separate sheet of paper, write your first number down, make 4 slots, and just fill them in, and you write the last one. Okay, there's some other ones that have 2 steps, but it works the same way. So I'm going to write an 8 first, and then 4 slots. And then I'll just do the things that it says. So times -4 would give me -32, plus 4 would give me -28. Times -4 would give me, I'm just trying to quick do this in my head here, if I do -4 times -28, I'm going to end up with 112, positive 112, and then if I add 4, I get 116. And I do times -4 again, I'm going to have -464, plus 4 would be -460. And then if I do that times 4, I'm going to end up with positive 1840, plus 4 would be 1844. Okay, so that's as hard as they'll get in that section, but you just use a calculator to help you and follow all the steps, and you should be able to generate that 5th term. All right, second task looks like this. There's 2 blanks to fill in, so you're just writing the formula. So A1, you're simply going to look at the beginning of the sequence and type that number. When you go to do the rest of the formula, first you have to figure out what's happening here. So this is a multiplication formula, and because the signs are switching, it's times -5. So when I go to write that, I can put a -5 first, and then I can just click this button here, and it will automatically insert and a(n minus 1. And that's how that goes. So if all it is multiplication, type the multiplication number first and click that button. Or you could have one like this. I'm going to put that 19 in first. And this one is going down by 10 every time. So I would click the button first, which would put a(n minus 1 into the formula, and then just type minus 10. Okay, so if it's add or subtract, click the button first. If it's multiply, then put the multiplication number first. Okay, third category is asking which formula it is. So it's multiple choice. So when you do these, you look for the first term, but they didn't give anything away there because all 4 of these have the correct first term. So what we're trying to figure out is which of these formulas is correct. So going from 10 to 35 to 135, these are all showing times something. So what you could do is just test it. So if it's the first one and you did 4 times the previous term 10 minus 5, do we get 35? And we do. So then we try it again. You try 4 times 35 and subtract 5. Well, this is 140, and if I subtract 5, I do get 135, so that turns out to be the right answer. So if it doesn't give anything away with the first term, then try the rules that it presents you to figure out which second component of the rule is correct. All right, that should get you there. So with any time remaining, work through your delta math. It's due on Friday.